So basically the real trouble is gonna arise when we don't have the graph of a function. We don't have the graph of a function when we just have the equation. So how are we gonna deal with that? So we will use calculus to help us deal with finding the relative mean, relative mass, or the inflection point of a function. But first, let me actually give you guys a quick review about the feature of the graph. A function is positive if it lies above the x-axis. So anything that lies above the x-axis is going to be a positive function. If my function lies below the x-axis, if it kind of has to be down here, it's called a negative function. So positive and negative is just the sign of the function value. It's positive if the y value is positive when it lies above the x-axis. A function is negative when it lies below the x-axis, when the function value is negative. A function is increasing when it goes up. A function is increasing when it goes up. It doesn't matter where the location of the function. It can be below the x-axis, it can be above the x-axis, but as long as it goes up, then it's increasing. A function is decreasing when it goes down. Once again, it doesn't matter if my graph is below or above the x-axis, as long as it goes down, then it's decreasing. And again, just like I just said, the function concave up if it looks like a U or half a U. And concave down if it looks like half an N or half an N. Concave down. So again, these three features of functions whether my function is positive or negative, whether my function increasing or decreasing, whether my function concave up or concave down, the three features work independently, so they have nothing to do with each other. When a function is concave up, it can actually be decreasing or increasing. It can actually be increasing nor decreasing when it goes down. My function can be either positive or negative when it goes up. It can be positive or negative when it goes down. So these three features, they operate independently on a function. However, when you take derivative, there are some relationship between these guys. So that's going to be what we will talk about next. The first thing that we can observe is that if I have a function, if I have an increasing function, so when I have a function that is increasing, it will tend to go up. When it tends to go up, that means it's gonna have a slope. When you draw a tangent line, it's gonna have a positive slope. And when it has a positive slope, that means the derivative is gonna be...
What does that say? Increasing?
Oh, increasing.
Increasing.
Yes. Let me